and the low salinity zone related to Phase 2 of the State Water Resources Control Board's review of the 2006 Water Quality Control Plan for the Bay Delta Estuary. I am Fran Spivey-Weber, Vice Chair of the State Water Resources Control Board, and with me today are board members Tam Doduk and Stephen Moore, and Felicia Marcus will be joining us just within the next few minutes. Also present are Rich Satowski, Senior Engineer, Diane Riddle, Environmental Program Manager, and Dr. Brock Bernstein, a subcontractor for ICF International, who is the workshop facilitator and has ably put together all of these panels that we've been hearing. Before I get started, I need to repeat the evacuation procedures for those who were not here yesterday. Please look around and identify the exits that are closest to you. In the event of a fire alarm, we are all required to evacuate the building immediately. Please take your valuables with you and do not, there are no elevators to use, so don't worry about that. Exit down the stairway, go to our relocation site across the street at Cesar Chavez Park, and turn off your cell phones. Now, please. I will now turn it over to Brock so we can get started.
Also, in the back are blue comment cards. If you want to make a comment during the public comment period at the end of the day, please fill that out and get that. Just drop it on my desk, and then I'll pass that off to the board vice chair at the end of the day. Also, for speakers in the front of the room, we found out yesterday that even if your microphone is off, if one of the other microphones on that table is on, people listening in remotely can hear what you're saying. So either be quiet or say really, really complimentary things about the other speakers and the board and the whole process, things like that. So the first speaker, the in Delta Water Interest panel has a set of 5 speakers, and Linda Dorn from SAC Regional is going to introduce the first 3. And so can you turn that mic on? Great.
Is this mic on? Okay. Good morning, Vice Chair Spivey-Weber, board members. I'm Linda Dorn with Sacramento Regional County Sanitation District. I'm an environmental program manager there.
Linda, it may be on, but you need to get really close to it.
Okay, is that better? Yeah. Okay. And first, I want to thank you for the opportunity to inform the board on this update to the Bay Delta Plan. And Sacramento Regional County Sanitation District has been and will continue to be a strong supporter of sound science. And we also want to relay to you our support from the 2009 staff report regarding contaminants and nutrients, and that they be addressed through processes that already exist with the regional water boards. Nutrients have been discussed and will continue to be discussed. With this panel today, Dr. Michael Connor, representing the Bay Area Clean Water Association, will be talking about nutrients and the Bay Area. And Dr. Connor is currently the general manager of the East Bay Dischargers Authority and was the executive director of the San Francisco Estuary Institute. Presenting on behalf of Sacramento Regional County Sanitation District will be Dr. Mike Bryan with Robertson Bryan Incorporated. He has over 21 years of experience in consulting and research regarding water quality, toxicology, and fisheries biology. We also have Cameron Irvine of ch1-10 Hill, who is an ecotoxicologist with over 15 years of experience with projects throughout North America. So with that, I just wanted to take a brief moment to introduce the folks that will be talking to you representing wastewater. Thank you.
Good morning, board. I'm Mike Connor. In addition to Linda's introduction, a lot of my comments come from my 40 years experience in this issue, mostly on the East Coast, wearing a hat as a EPA regulator, as a nonprofit person, and as an academic, and as on the Boston Harbor cleanup working for the Mass Water Resources Authority. I put some science-related comments in the written testimony. I thought for the oral I would talk more about sort of this science policy intersection that came up yesterday as you were talking, try to think of ideas of things that the state board could do to make this process work a little more better. And so the two pitches I'm going to be making to you is to improve the geographic and agency collaboration on environmental management of the Bay and the Delta. And I think there are three areas that that you can focus on. One is the Bay Delta numeric nutrient endpoint process, getting them together rather than separately. It makes a whole lot of sense. And I'll talk about that a little later. The next is monitoring coordination, trying to figure out how to pull the monitoring pieces together. Jim Claren mentioned these two next items, and I agree strongly. Everything Jim says is wise, and I agree with what he says. He's a little vague on the details, and I was going to try to fill that in a little more. And then the integrated modeling strategy was also a piece that he made, and I think that is also to try. Let's think about a little about how we might do that. And then this question of how to deal with scientific uncertainty that came up in your questions yesterday. And as I heard the presentations, it's clear we're going to have scientific uncertainty no matter how much science we do on this. And the timing of that versus the timing of decisions you have to make is going to be tricky. And I think you have some examples of joint fact-finding processes that have been underway and working reasonably well that I don't think there's any way to do better but through that. The problem we have as managers and as scientists is that the productivity drivers in the Upper Bay, the science drivers in that, aren't matched by either the governance silos or in some ways the science silos that people get themselves in. So we have flows, we have nutrients, we have light, we have microbial processes. Generally, scientists will work on one or two of those, and integrating them together doesn't happen that often very effectively. And there's some counterexamples. Some of the tremendous work done through the Bay Delta Science Program has started to pull that together. But in general, we have that problem. The problem on the governance side is flows is generally DWR, thinking a lot about that. The contaminant issue is generally the water board. The resource side is generally fish and game, and those never quite fit together very effectively. And so we need to do a better job of combining those staffs because we don't have the resources statewide that we're going to be able to do all of them in separate organizations. And so we're going to have to figure out how we push the organizations together better. So one piece that's worked well, I think, is the joint fact-finding process where there's research and monitoring that is done towards some of the issues that have combined both agency scientists, outside scientists, some of the groups that are affected by these things, mostly in the funding aspect, but then they are participating in a way to get at the data and try to figure out how to use it. And so the Interagency Ecological Program has certainly been around a long time as a good example of that. The Bay Delta Science Program has pulled that off very effectively. In the Bay, Down Bay, the Regional Monitoring Program at Region 2 is set up, is now very closely coordinated with the stormwater monitoring requirements that the regional board put into the stormwater permits. And for the Steve Ritchie deal that was back 20 years ago that Steve was part of was to essentially say we're going to reduce requirements for far-field monitoring for all the wastewater agencies if you combine to a joint regional program. And that's worked extraordinarily well of joint ownership, of everyone agreeing basically on the science. They still fight about stuff, but at least they're semi in agreement on the facts, and then it's just how much safety, what the safety factors you use are. And then this, recently in the Bay, the San Francisco Bay Numeric Nutrient Endpoints, which has been sponsored by the State Board and led by staff at SFEI and SWRCB. There's some gaps, and the gaps are upstream nutrients. The board made a decision not to cut the bay off just at Region 2 rather than combining Region 2 and Region 5's efforts on nutrients. And that's a real miss. And a lot of it was made, I think, just for resources available, that they made a practical decision that just we don't have the money to do that. But we need the money to do that, and we need to figure out how to do it. There's got to be a way to do that. And we're still doing while we know loadings from the wastewater side quite well, we really don't have a good sense of agricultural loadings and how they differ with land use types, and that's a crucial piece of data that would really help us. The modeling synthesis, as Jim said, also is not working very well. There's a lot of good models, but we haven't pulled together. Ultimately, we're going to need a model that combines the best we know about flows, the best we know about phytoplankton microbial processes, and how does it affect the fish that we're worried about in the bay. Each of the agencies tends to throw into permits required studies, but often then that's down at the regional permit writer level, and those studies, I have to say, don't fit together. The agency person is trying to be the best scientist they can, but they don't have that big overall perspective. And as the NRC was saying, these are really complicated problems, and somehow we need to be sure they fit in with the overall work of the Science Policy Board, either led through the Bay Delta Science Program or somewhere else. But I think, in fact, we know the Bay Delta Science Program works. They're not going to want me to say this, but I think we need to expand how they do this. They're overtaxed already, but maybe we can be lending them staff from different agencies. Somehow, it's crazy to have different agencies trying to summarize the science as best they can for different reasons, and we need to pull those together better. The other piece that is lacking a little bit in some of these programs is public participation, and on the RMP we have the Save the Bay involved, and also the Baykeeper, so they're sitting on some of our committees. So as a result, the joint fact-finding involves them too, and there's some overall agreement. That works less well with IEP, and there's less integration of that together with IEP. It's working well in the Delta RMP. They're trying to take that into that, but I'm not clear that the Delta RMP is gonna does the science well enough, and that maybe we need to figure out how to combine the Delta RMP with the interagency ecological program. Oops. So backwards is that way. So on this integrated modeling framework, that a lot of times, because people are focusing permit by permit rather than at the whole bay overall, they often look at little small areas just to explain what's going on in that permit. And later people will be talking about specific permit concerns they have. I'd rather take the bigger piece of this. But ultimately, we need to have good conceptual models and numerical models that explain. We've got a lot of good data on spatial trends, temporal trends, and we talked a little yesterday about natural experiments, and there are a number of natural, so to speak, experiments that have been underway. Unlike for the water side, we still haven't pulled all the nutrient data from historically together in as long a good data set as we need. And in my writing, I submitted some data back that we have the best schools in the country at this stuff, though they're generally not the best school on nutrient issues, but they're good. And we need to, as we look at these, we see that back in the 50s, that the difference in concentrations in ammonia and nitrate haven't really changed a heck of a lot in the bay over the last 50 years. The big changes we're seeing are when the South Bay put in secondary and nitrification, so as a result they reduced their ammonia down to quite a bit and raised their nitrate. The ammonium levels throughout the bay aren't that different, and the nitrate aren't hugely different. So as we're explaining results of the bay, as you look at the chlorophyll, and here we're going from from up in Suisun Bay through a transect down to San Jose, and I've laid on these the sort of the upper number, since they're too small to read, of we're at 8 in Suisun Bay and up to 50 in the South Bay. And our models of what's going on with water quality need to explain how it is that we're getting very different responses bay-wide, and those same processes that we come up with need to be working in the Suisun Bay and in the South Bay. And so a lot of the debates we're having on what drives Suisun Bay, as we're looking at what's going on in South Bay, we're sort of scratching our heads, well, what the heck? Well, you got to explain the whole bay. You can't just say what's going on at one location. As we do have reasonably good long-term data sets that are important in building in conceptual models, and we should be using them more intelligently. This shows the Suisun Bay ammonium, as we talked, as it was presented very clearly yesterday. We are seeing a very strong response in chlorophyll. As you look at the long-term ammonia data, you're saying, well, jeepers, it's hard to totally explain that, how that's affecting chlorophyll. And in fact, we do have natural experiments that have been done. We talked yesterday about the clams. There's also another interesting natural experiment that was done that Contra Costa Central Sand did a lot of work on nitrifying its effluent in the 80s, not perfectly, and it was hit or miss at times, but that's how they originally had built the plant. And so a lot of the things we're advocating is saying, hey, everyone needs to nitrify. We're hard-pressed to see any impact from nitrification in the Suisun Bay data set as you look at the overlap of time. Need to have different models to look at this issue more carefully, but we do have these natural experiments that we can take advantage of, and we do need to take advantage of. The third point is, as we look at these issues, this shows seasonal loading from the rivers into Suisun Bay of ammonium, and between the old 75 to 86 and then 87 to 95. But by the way, all these data I'm using from the numeric nutrient endpoint work that Dave Sen at SFEI and Martha Satula at SWRCB have done. So I'm just using their work, and I apologize to them for, they haven't totally agreed with everything I say. The interesting piece of this is that it does show that there's a difference, a big difference in how the bay is responding to, how the bay is getting nutrients in the summer and winter. The interesting piece of this is wastewater loadings are pretty much flat year-round. So the higher loadings in the wet season have to do with runoff, and also with ammonium, we're also seeing a lot of microbial processes, nitrification in the bay and plant uptake, but it's changing how the bay responds quite a bit. And this is also important for the solutions we come up with, whether or not we require full wet season treatment of nutrients or just during the warmer season. It makes a big difference in the outcome to what it's going to cost for agencies to figure out what to do. So as we're setting our policy amidst these large scientific uncertainties, I think there are a couple points that we need to remember. One is that we're trying to balance joint multiple uses that are going to require really large societal resources. And sometimes the people overlook the fact that the agencies speaking today are essentially governed by the same citizens that you represent. We have elected boards, and we are the people that are trying to essentially, I think in ways we are partners with you. We're trying to implement what you come up with, and we have to explain to our ratepayers, our board members, how this is going to make a difference. And my board always tells me I want to spend every dollar necessary to make sure San Francisco Bay is healthy, but I don't want to spend 1 penny more. And I need to make a clear case as to what are we going to see as a result of this spending this money. The waste that we've talked about the water cost being in the tens of billions of dollars. Our estimates, depending on what amounts of nutrient removal we do, we're also talking tens of billions of dollars for the wastewater cost. And if you have really, the other issue that the state board's really going to have to grapple with is to what extent is the basis on which you make decisions here, do you run statewide? And I think the sewage girls and Steve have been thinking about some of these issues, and I think ultimately this is you're doing capital planning for us. Now it's capital planning without any money. Unlike the Clean Water Act, we don't have the societal resources at that point to, if we're talking tens of billions of dollars, I think the state grants program is running $250 million a year or something like that. There's just not going to be the outside funding. And so what got the Clean Water Act going was federal match of 85%. So we're going to have to be, as we look at these issues, we're going to have to figure out how we pay for them. The costs are regressive. They're mildly regressive to severely regressive. Poor people, and the problem is our expenses are not very flow related. It costs us almost as much to give water and wastewater services to rich households as to poor households. So even if we charge more on flow-based rates, as NRDC is recommending, it's still not going to make a whole lot of difference to somebody if they're paying $1,000 a year in sewer bills. That's a lot different for a person who makes $25,000 for a person who makes $250,000. So as a result, we have to figure out, make sure we're addressing the right issues and setting the standard for the future in the proper way. The other thing is, for the agencies, we have a number of things we're trying to deal. We're trying to, in the wastewater agencies, our movement is from wastewater treatment to thinking of it as resource recycling. And the most valuable piece of wastewater as resource recycling is the water. And then after that comes energy. And we have to deal with the Air Board on these issues and try to figure out how can we maximize water recycling, energy recovery, and then N&P reuse either as nutrients or turning to nitrogen gas. So I think the best way to do that is to work closely, is to strategize with you over those issues and how are we going to implement the future plans for nutrient reduction. As you see in the states of Colorado and Montana, there's some really interesting examples of how the states have been trying to implement EPA's requirements for nutrient removal. I talked a little about nurturing joint fact-finding with permitting, and then also in Region 2, there's been a big emphasis on taking no-regrets actions. What things can we do that are pretty easy to accomplish, make a lot of sense, and we can get everyone to buy in quickly? And I think from the wastewater agencies, we have to come up with some good ideas there to make it work. So as I mentioned to begin, I had 3 major pushes for you, and one was to improve the collaboration. The second was trying to balance the scientific uncertainty as you make policy decisions. Thank you very much.
Mike, you can go ahead.
Okay. Good morning, Vice Chair Spivey Weber, members of the board. My name is Dr. Michael Bryan, and I'm a managing partner with Robertson Bryan Incorporated, and I'm here today speaking on behalf of Sacramento Regional County Sanitation District. I submitted written materials that addressed new scientific information associated with contaminants, specifically pesticides and CECs, and also going to be beating on the same drum a little bit today that you've heard from Jim Claren and Michael Connor here, and that is the need for a comprehensive Delta monitoring framework. And I think there's some opportunity for the State Board to be a leader here associated with its Water Quality Control Plan implementation program, and the update of that is associated with the update of the plan itself. So this presentation attempts to integrate those two topics that my written submittal was on. So why a comprehensive delta monitoring framework at this point in time? You've heard a lot already. I'm going to attempt to add to that and give you a little bit additional perspective. Many valuable monitoring programs exist today. New ones are going to be coming online. And obviously this is extremely important to all of us, including your organization, to provide that scientific information to make good management regulatory decisions. But as you also know, each of these programs has its own limited focus. So coordination and integration among these monitoring programs is essential to supporting the Delta Stewardship Council's co-equal goals of the Delta Plan, and to ensure consistency of things such as the Bay Delta Conservation Plan and the update of your Water Quality Control Plan, and to assure that those major efforts are consistent with the Delta Plan itself. So we need a unifying monitoring framework that integrates current ecological, hydrologic, and water quality monitoring programs in order to ensure that these major Delta initiatives work together synergistically. So the program of implementation for the Bay Delta Water Quality Control Plan provides an opportunity, as I mentioned, for the State Board to partner with a Delta Science program and others to develop a comprehensive Delta monitoring program. To do so, the State Board's implementation program could coordinate and integrate under an overarching scientific vision of Delta ecological and hydrologic function. The Water Quality Control Plan's implementation program needs to fit within a comprehensive Delta monitoring framework, which really doesn't currently exist and therefore needs to be further developed. By providing such a comprehensive science-based framework, the State Water Board can effectively harness the data gathering power of multiple monitoring programs, those that cut across multiple disciplines, to produce the information needed to most efficiently and effectively evaluate the efficacy of your initial flow objectives, and then of course for making adaptive management decisions down the road. So where are we today with Delta monitoring? This slide kind of depicts a little bit of where we're at today. We've got a lot of great monitoring programs out there. We've got the Bay Regional Monitoring Program. We've got the new Delta Regional Monitoring Program coming online. We've got lots of individual studies by academicians and others. The coordinated regional monitoring program that SAC Regional is involved with. We've got DWR's Municipal Water Quality Investigation, focused of course on water quality. IEP focused on ecological endpoints. But as these arrows depict, great monitoring programs providing tremendous information to this board and other parties, but they all have their individual focus. They're not necessarily harnessed in a common direction. So this is where I think we need to be with Delta monitoring, or at least a direction that we need to move further. We need a comprehensive scientific Delta monitoring framework to direct coordination among existing monitoring programs, one that integrates ecological, hydrologic, and water quality data in search of fundamental relationships that cannot be seen easily from individual non-coordinated programs. So the State Board can play a vital role here. An efficient program of implementation for the Water Quality Control Plan can rely on current and expanded Delta monitoring programs to provide the State Board with the data it needs to judge whether the flow objectives are producing the desired environmental conditions. I think your implementation plan should put forth monitoring requirements that make coordination among these existing programs and integration among the disciplines, the water quality, hydrology, ecology, a true emphasis. Coordination of monitoring without a comprehensive scientific Delta monitoring framework to direct such coordination, one that does integrate ecological, hydrologic, and water quality data in search of those fundamental relationships, I think will fall short of what's needed. Recent efforts, for example, to determine the causal relationships between contaminants in the pod were not fully successful due to fundamental deficiencies in the way that monitoring has historically been conducted in the Delta. And you can see Johnson et al. As evidence of that. While this study could not completely eliminate contaminants as a cause or a contributor to pod, the study did conclude that contaminants were unlikely to be a major cause of the pod. A comprehensive scientific monitoring framework is needed to define appropriate measures of delta ecological health and how they're affected by flow, by water quality, by species interactions, including invasive species. You know, such a framework could involve the following: conceptual models of ecosystem function and the effects of CVP, SWP operations, other stressors, climate change on those ecological functions. The definition of desired ecological and water supply target conditions. What do we want out of our delta relative to our co-equal goals? Definition of performance metrics and measurements used to evaluate successful acquisition of those desired target conditions. This is where it gets a little more difficult, a little more interesting. We need to be taking the right measurements in the right locations at the right time so that when we analyze that data, we can develop the metrics to determine whether we've achieved those target conditions, and if we're not there yet, are we on the trajectory to achieve them? And of course, an adaptive management component that directs future actions and monitoring consistent with the framework itself and the technical findings that are constantly being updated. So an example framework may look something like this, which I've adapted from Luoma et al. 2011. And we start with key questions. And these are questions that I think this board, as it gets involved with developing such a framework, can be sure that you pose the questions that you need to have answered. We can start with a series of major questions and then go to sub-questions. How will delta flow objectives, for example, affect water quality? Major question. How will new delta flow objectives affect salinity, contaminants, specific contaminants, organic carbon, turbidity? How will new delta flow objectives affect listed fish species? Major questions. Sub-questions. How will it affect delta smelt, longfin smelt, steelhead, etc.? Then we can develop conceptual models of the functional relationships that define and affect the target conditions that we seek. And then lastly, we need to identify, and this is the difficult part, the specific measurements. What measurements? Where do we need to take those measurements? With what frequency? With what data quality? So that when we put that data together, when we analyze it, that we can develop metrics and indicators of whether those target conditions are being achieved. And if they're not being achieved, what trajectory are we on? Are we moving in the right direction? Are we moving in the wrong direction? When do we anticipate, if ever, to achieve those target conditions? So using pesticides as an example, a question might be, how will new delta flow objectives affect pesticide levels in the delta watershed? Conceptual models can help us pose interesting questions. Changes in system hydrodynamics could change the pattern of organism exposure to pesticides through the change in the simultaneous occurrence of organisms and pesticides in time and space. So our target condition obviously would be something like no pesticides in toxic amounts. Again, we have to identify the key measurements: where, when, at what frequency, at what quality, so we can develop the metrics and the indicators to see if we're achieving that target condition. So staying with this pesticide theme for a moment, I'll now address some of the new studies and how they can contribute to the development of a comprehensive delta monitoring framework. Hugwig et al. 2011 performed a risk assessment whereby spatial and temporal co-occurrence of listed species with that of 40 different present-use pesticides were estimated. Pesticide loadings from sites of application were estimated based on various environmental fate models. In both spatial and temporal estimates of concentration were depicted, and indicator days defined as a risk quotient greater than 1 for at least one pesticide were developed, and that's the figure that you see on the left here. So this is a look at the relative levels of pesticides throughout the watershed, with the yellow and light green being low levels, infrequent levels of pesticides at levels that would adversely affect aquatic life, up to the dark blue areas where there was a large number of indicator days indicating higher concentrations more frequently. The spatial and temporal occurrence of special status species were then combined with the indicator day estimates in a manner allowing approximation of toxicological risk, shown in terms of the 80th percentile co-occurrence, and these estimates are shown in the right figure in the green shaded areas, with the areas of greatest concern shown in the red stars. So this can help us target where we need to do our monitoring. Are we monitoring the right things at the right locations? Also, these tools can be used to, as time goes on and new chemicals are used, land uses change, we can use these tools to update where we're doing our monitoring. Decisions to engage in monitoring need to obviously reflect current state of the science. For example, some recent POTW pyrethroid studies conducted by my firm for the city of Vacaville and similar studies conducted by others for SAC Regional demonstrate shortcomings of current conceptual models and the need to update those models by considering bioavailability of pyrethroids in effluent, not just total recoverable concentrations, if we're going to do a good job of estimating toxicity, and that's shown in these two figures here. The conventional model is on the left, the total recoverable. And so here we were looking at various pyrethroids with a similar mode of action. We would sum up their concentrations on a total recoverable basis and define them in terms of toxicity units and try to predict actual toxicity. But we didn't do a very good job with that model to predict toxicity. You see one green data point over on the right at about 3 toxicity units, but only a 20% effect. If that model were functioning properly, that effect would be up at a 60 to 80% effect level. So when we looked at the dissolved fraction, which better approximates bioavailability of pyrethroids, we get a much better fit to the model. We can now, once we understand bioavailability of these pesticides in effluent, we can better predict the toxicity that we're going to see. So the upshot of these studies, along with Don Weston's more current research on the same topic, is that it further confirms that although we can detect pyrethroids in municipal effluent, they're not at concentrations that are adversely affecting aquatic life in the receiving waters. A recent POTW constituent of emerging concern study, also conducted by my firm for the city of Vacaville, demonstrates shortcomings in existing sample preparation and analysis methods, leading to considerable data QA/QC issues related to CEC monitoring. The study concluded that widespread acceptance and use of standardized sample preparation and analysis methods is necessary before appropriate monitoring and regulatory paradigms can be implemented. So in short, the analytical methods are simply not there yet for broad-scale CEC monitoring programs throughout the Delta. So wrapping up with some recommendations. Again, I think you have a real opportunity with the update of this plan and your implementation program associated with it to orchestrate interdisciplinary collaboration that's necessary to develop a comprehensive scientific Delta monitoring framework that includes the key questions that this board needs to have answered. Such a monitoring framework could, by design, focus our multidisciplinary monitoring efforts to produce the data needed to judge the efficacy of your initial flow objectives and produce the desired environmental, and see if they're producing the desired environmental conditions, and attempt to answer other specific questions that you need to have answered while continuing to still cater to the original focuses of those programs. It's more of a harnessing in the synergy that comes with a common framework. I think this board can partner with the Delta Science Program and other scientists that you've convened for this workshop to develop such a framework. It's partly developed, but I think it needs to go further. And you're not on your own to do this. I think you can rely on the scientists that, again, are providing you information at this workshop in the Delta Science Program to help you do that. Use adaptive management to refine the framework and the questions over time, and the monitoring program elements over time. So what we need to hit hardest for monitoring tomorrow is not going to be the same necessarily 5 years from now. And finally, seek refinements in how and when you apply specific objectives. So your current paradigm in your current water quality control plan, you have the 5 water year types. And certain of your salinity objectives, for example, are imposed based on the hydrologic year type. Well, we heard yesterday from DWR that all wet years are not the same. Wet is not wet. And so you may need to have some further refinement of these hydrologic conditions. You may need subcategories of wet. You may need 6 or 8 or 10 hydrologic conditions defined so that based on that, you can determine how best to apply your various flow objectives. And lastly, I would encourage you to break adverse hydrologic trends while avoiding breaking the hydrologic bank. And I think a great example of this we heard yesterday, I think it was EPA that presented the slide. There was a lot of information yesterday on X2, but the one that caught my attention was, other than last year, 2011, where we hit the 75-kilometer mark, for I think a decade prior to that, X2 was flatlined at 83 kilometers or higher in the system. Well, that's an adverse ecological or hydrologic trend. There's still a lot of controversy over just how we need to manage X2 to restore delta smelt, but I think you have a lot of agreement that if you flatline X2 at 83 kilometers or greater for a decade or more, that's probably adverse to delta smelt and the ecology. We can break that adverse hydrologic trend, but we can't push it so far that we're breaking the hydrologic bank, because once you go there, really all you're doing potentially is trading an ecological impact for a water supply impact. So with that, I'll conclude, and if you have any questions, otherwise I'll pass it down the road.
I don't have questions right now, but Brock, I just wanted to give a heads up to the Sterling invited expert panel from yesterday, who are all sitting together, which is convenient. I'm going to be interested in your comments on particularly these suggestions and recommendations as to how to further integrate some of the ideas that they have on water quality with what you are actually doing. And you don't all, I don't expect all of you to get up, but among yourselves figure out who might respond to that. And don't tell us that you need more money and more staff. That's really not the point. The point is, you know, is that something you can work with? Is it do you see that it would be useful from your own investigations in terms of ecology, et cetera?
Just a quick question for Mike, following up on your presentation. How quickly could you whip out a monitoring framework for us?
Tomorrow, soon enough? No, I know it'll take time.
At what cost? Tom is in the room.
It'll take time, and but I think, again, you have the resources here. I think one of my major themes is you guys don't have to do that yourself. I think you can be a leader here. I think you can pose the right questions, and the questions that you're posing are among the right questions, right? So the monitoring programs that are ongoing have many of the right questions being posed already. But it's a classic situation if you're trying to address 2 or 3 questions and you have the 4th question, and it's only after the fact that you go to the data sets to answer your 4th question, you may or may not really be able to get there. We want to see those questions up front in a framework so that a real quick example, if you're going to go out and do a fish survey and you're trying to look at fish abundance by different habitats, and so you go do that survey, but you don't bring a YSI meter with you, you don't take any temperature data. And after your survey is done, somebody asks you, could you tell me if species X ever occurred above temperature Y? Well, most of the effort to get out there is to get out there in the field, and to do that survey, all you need to do is tack on, this is a simple example, I know, but take some temperature measurements. The only way you would know to do that is if you knew that you wanted to relate the data that you found to temperature. So I think by getting those questions up front, by orchestrating the framework, we're going to be in a much better position. It will take some more money. It'll take some expansion of programs, but there's synergy there that you're not fully capitalizing on.
Okay. Next speaker, Cameron Irvine.
Thanks. Good morning, board members and Vice Chair Spivey Weber. My name is Cameron Irvin with ch1-10, and I'll be speaking to you on behalf of the Sacramento Regional County Sanitation District. You're tackling a very complex issue, and I thank you for the opportunity to share some information that I hope will be helpful in your review of the Bay Delta Plan.
Could you get closer to the microphone? I could barely hear you.
Okay.
Thanks.
So I hope the information I provide today will be helpful in your review, in addition to the wealth of good scientific information that has been produced by Delta scientists. Is that better? Okay. So the State Board requested new information and new technical information and how to address uncertainties among the topics for this discussion. And I'd like to primarily address uncertainty and provide examples from the new scientific information to illustrate these points. Scientific uncertainty is generally what we don't know. It always exists, and that should not preclude decisions, but you should understand that it's variable and it should inform your management decisions. The weight that you might give to a particular line of evidence can be informed by how much uncertainty it has, and that relates to how much confidence you have that a decision will produce the desired results. It can also inform, uncertainty can also inform adaptive management, and that's why I've included this figure on adaptive management from the draft Delta plan. And it's the steps in the blue section, evaluate and respond, is where uncertainty can be addressed. The Delta plan describes adaptive management as hypothesis-driven experimentation and research is particularly useful when working to shrink large uncertainties. So on a large scale, you're trying to understand the system better. But NRC also described AMPs as that can include plans for studies that are intended to reduce uncertainty. So uncertainty fits into the AMP where you find you need to understand something better because maybe you're not getting the response you want, or there's uncertainty that you already know you have, but need to further tweak it. And so studies can be designed to address that uncertainty. One approach to managing uncertainty is, as has been used and is supported by SAC Regional, is to have multi-agency stakeholder groups and discussions. The IEP and pod contaminant work team are among these groups, blue ribbon expert panels, and workshop proceedings from events like the Ammonia Summit, which produced a framework for ammonia research, the low salinity zone workshop, DRERIP conceptual models, San Francisco Bay NNE, as described by Mike Connor, and the Bay Delta review expert panel we heard from yesterday. A specific example of an expert panel is the monitoring strategies for chemicals of emerging concern that was developed for SWRCB. Technical experts representing government, consulting, and academia convened to produce this document. They recommended a proven risk-based approach for evaluating contaminants of emerging concern. They recognized uncertainties, such as that they did not address non-point sources, and they identified data gaps for research, such as refining and developing new analytical methods. So this panel did a good job of recognizing and reducing the uncertainty associated with this plan. Problems can arise and arguments over data can be developed when data are of unknown or poor quality. And scientists, decision makers may not agree on how to interpret the data, as we've seen in the Delta arena. So one recommendation for the board is to encourage or require the use of data quality objectives in study planning. This is a procedure that's described by the US EPA, and it's required for EPA projects under the Data Quality Act. And it includes, a good study plan also includes good quality assurance, quality control. So the DQO process describes the problem that's to be addressed and the conceptual model in which it occurs. It describes the eventual decisions or estimates that are to be made, the type of data that are needed to answer those questions, how the data will be used to draw the conclusions, acceptable data quality criteria, and finally, the investigation design or the study design. So this helps to produce validated data of known quality. It reduces uncertainty with this data and how it's used, and it supports management decisions. So managing uncertainty is also conducted where you collect the data and then you have to validate it. So the DQO process covers all of this. It describes how the data will be collected, but once you collect that data, there's the data validation. Data that meet test acceptability criteria are of known quality and are accepted, but data without adequate QA/QC or do not meet test acceptability criteria are certainly questionable. And if you don't have those QA/QC in the first place, you don't understand the quality of those data. And once the data are produced, reporting and interpretation is important. where conclusions beyond the scope of collected data are not defensible and should be evaluated with further testing, and that could be a recommendation in a report. Speculation should be qualified, and uncertainties described in the reporting. One example of a study that has concerns over data quality was conducted by UC Davis researcher Suisun and colleagues, where they investigated the toxicity of ammonia to a copepod. This is a novel test species, and so that has its own unique uncertainties. But in reviewing the report, a respected toxicology lab, Pacific Eco Risk, who's performed thousands of toxicity tests and is well versed in these procedures, described this report and study as there are problems, and this is in the quote in the box here on the screen, problems associated with experimental methodology and significant questions regarding the analysis of the resulting data should preclude them from being used for regulatory purposes. And I paraphrase that. So there were significant concerns with the data, and unfortunately the Central Valley Board used this data in reviewing a permit without the benefit of having this peer review component. The issues can be corrected. The identification of concerns isn't a game ender. This can be corrected. The best way is probably to repeat the study, but by starting with a strong study plan that uses data quality objectives to identify quality assurance, quality control procedures, and the goals, and make sure all of the information that's going to be collected that will address the comments and concerns that were identified by the reviewers. If data of known quality and acceptable quality are produced in this follow-up study, this information would be very helpful to resource managers. As I mentioned, some uncertainty will always exist with testing novel species, and I just wanted to bring this point to light by illustrating an example from another UC Davis lab directed by Inga Werner, who studied delta smelt toxicity for several years, and it took a while for them to identify that turbidity and conductivity were two parameters that young delta smelt responded to. And so when they collected ambient samples, they were getting responses to these water quality characteristics and not necessarily to contaminants. And then they were able to implement controls for those. And so when using new species, there are definite uncertainties that should be considered. So a final step to managing uncertainty is in the peer and stakeholder review process. Researchers know that publications can vary in quality, whereas some publications have a thorough peer review process where an editor or referee will ensure that the comments by reviewers are adequately addressed, and other less formal peer review processes can occur where comments are provided and then the author can decide how and if those comments will be addressed. Uncertainties should always still be discussed and qualified and data gaps described, but it's important for comments to be adequately addressed. And a very good peer review process would include a way or inclusion of the comments and responses in a report or make them available to interested parties who are reviewing a final work so they can see where disputes might exist and how to interpret the data. So one example of this that I have shown is the algae chlorophyll A concentrations in the Sacramento River, which does feed into the low salinity zone. And